You ever see a poll and just wonder, how do they know that? How can they possibly figure out what an entire country is thinking without talking to every single person? Well, that's where the magic and, honestly, the science of sampling comes in. It is an incredibly powerful idea, and we're going to break down exactly how it all works.
I mean, it really does seem impossible, right? You're telling me a poll of just a couple thousand people can actually predict how millions are going to vote? It's not magic, it's statistics. And it all begins by admitting one very simple, very practical problem.
Look, trying to survey an entire population, whether it's all the voters in America or every single nurse in a hospital system, would just be a colossal waste of time and money. But the good news is, if you do it the right way, you don't actually have to.
And that is the core idea right there. Sampling is all about picking a small, representative group from a much larger population to figure out what that entire population is like. It's about getting a reliable peek at the bigger picture. But how you choose that small part, well, that's everything.
Okay, so to really get this, we first need to understand the two very different kinds of errors that can pop up. One is just an unavoidable fact of life in statistics. And the other is just a sloppy mistake.
Here's the absolute key difference. Sampling error is that natural, totally expected variation that happens because you're looking at a piece, not the whole puzzle. And that's okay. Statisticians plan for it. Non-sampling error, on the other hand, is a flat-out mistake. It's the researcher's fault. It means you messed up how you designed the study, and that can completely wreck your results.
So the starting point for avoiding those sloppy mistakes is what we call your sampling frame. Just think of it as the complete list of every single person you could possibly select for your study. It could be a list of all students at a university or all hospitals in a state. This list is your foundation. It's your source code.
So what happens if that list, that foundation is bad? You get a huge non-sampling error called undercoverage. Let's say you use an old list of company employees. Well, you're going to miss all the new hires. Their opinions are gone before you even begin. That's a classic sloppy mistake.
So, how do we do it right? Well, the gold standard, kind of like the North Star for all of this, is a method called simple random sampling. And it's all about making sure everyone gets a fair, equal shot. Now, what makes this method so pure is that not only does every individual have an equal chance of being picked, but every single possible group of people you could make also has that exact same chance. It's the truest, most unbiased form of random selection you can get.
You know, the easiest way to picture this is the classic names in a hat. You get a perfect list of everyone, you give every single person a number, you toss all those numbers into a giant virtual hat, give it a good mix, and then you just start pulling them out. Every single number has an equal shot.
And there's the catch. This method is beautiful in theory, but in the real world, getting a complete 100% accurate list of every person in a huge population is, well, it's incredibly hard. A lot of the time, it's just plain impossible. So what do you do then?
This is where we open up the researcher's toolkit. See, when a perfect list just isn't an option, we have other really clever methods, and each one is designed for a specific kind of problem.
Okay, let's imagine a high school. You've got tons of freshmen, a good number of sophomores, but only a small handful of seniors. Now, if you were to just draw a small, random sample of students, what do you think might happen?
Just by pure chance, you could easily end up with a sample of 10 students and not a single senior among them. And just like that, their whole unique perspective on the school would be completely gone. So how do we fix that?
The answer is stratified sampling. First, you divide your population into these meaningful layers, or strata. In our example, that's by grade level. Then you do a little mini random sample inside each of those layers. This absolutely guarantees you get representation from everyone. The catch? It's more complicated. You have to know your population well enough to create those groups in the first place.
Okay, but what if you don't have a list at all, let alone all the info you need for strata? Picture this. You're in an emergency room and you want to survey patients as they come through the door. For this, you grab a different tool from the box: systematic sampling.
And this one is wonderfully simple. You randomly pick a starting point, let's say the third patient who walks in. Then you decide on an interval, we'll call it K, like every fifth person. From there, you just survey the third patient, then the 8th, then the 13th, and on and on. It's super practical, but you do have to be careful there isn't some hidden pattern in the line that could mess up your results.
And for our last big tool, let's talk geography. What if you want to study something that's spread all across an entire state or country? Traveling to every single town would be impossible. That's when you pull out cluster sampling. I love this quote from our source material because it's just the perfect way to remember this. Cluster sampling is all about location. You divide a map into areas, or clusters, randomly pick a few of those clusters, and then you try to survey everyone inside them. It's incredibly efficient for big, wide-scale studies, but the risk is that the few clusters you pick might not perfectly represent the whole area.
So that's the professional toolkit. Simple random, stratified, systematic, and cluster. But there's one more method we have to talk about. It's the one you should almost always avoid.
Okay, so here's the fundamental difference. All the methods in our toolkit use randomness to fight bias and get a truly representative picture. Convenience sampling, it does the exact opposite. It's just asking whoever's easiest to find. Your friends, people on a single coffee shop, your followers on social media. The result is almost always a seriously biased, skewed picture of reality.
So, what's the ultimate takeaway here? It's that there is no single magic bullet, no one best method. The right tool always depends on the job you're trying to do. And the crucial thing to realize is this: the way you gather your information is every bit as important as the information itself.
So now you're equipped. You know the fundamental rules of the game. So the next time you see some headline about a new study or a shocking poll result, you'll know the single most important question you need to ask yourself. And that question is, how did they get their sample? That is the key that unlocks everything. It's what separates good science from sloppy mistakes and tells you whether you can actually trust what you're being told. And now you hold the key.